Hi everybody, today I want to explain about the logic gates. An electronic circuit operates on a logic is called logic gate. Logic gates are AND gate, OR gate and NOT gate. What is meant by an AND gate? This gate consists of two inputs and one output. Two inputs and one output. The output is A dot B. The output is A dot B. So, truth table of AND gate A B A dot B 0 0 0 dot 0 is 0 1 dot 0 is 1 0 dot 1 is 0 1 dot 1 is 1. Second gate is OR gate. This gate consists of two inputs and one output as usual. A, B are the inputs. A plus B, this is the circuit symbol. A plus B is the output. What is the truth table for OR gate? A, B, A plus B, 0, 0, 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 1 is 0, 1 plus 1 is 1. So don't think 1 plus 1 is 2. It is a logic addition. 1 plus 1 is 1 only logic addition. The third gate is NOT gate, means negation. One input and one output. A is the input, A bar is the output. That means 1 bar is 0, 0 bar is 1. So the truth table is A bar. If you take one input, 0 output, 0 input, 1 output. So 1 bar is 1, 0 bar is 0. Next, NAND gate. NOT gate plus AND gate is NAND gate. So AND gate AB A dot B, negation if you add to this A dot B bar. So the circuit symbol of NAND gate is AB A dot B bar. So truth table for NAND gate AB A dot B bar 0 0 0 0 bar is 1. 1 into 0, 0, again 0 bar is 1. 0 into 1 is 0, 0 bar is 1. 1, 1 is 1, 1 bar is 0. Next gate is NOR gate. NOT plus R is NOR. So OR gate you take AB inputs, A plus B output for OR gate, negation, A plus B bar. So this is the circuit symbol of OR gate. So what is the truth table for NOR gate? NAND gate, NOR gate, A plus B bar, 0, 0, you will get 0, 0 bar is 1, 1, 0, 1, 1 bar is 0, 0, 1 is 1, 1 bar is 0, 1 plus 1 is 1, 1 bar is 0. NAND gate and NOR gates are called universal gates. Any gate can be drawn from these two gates. That's why NAND gate and NOR gate are called universal gate. Suppose NOT gate can be drawn from the NAND gate. So see, this is the NAND gate. The two inputs signals, the two inputs you combine with a Y, it becomes a single input, either A or B. So NAND gate symbol is this. So A dot B bar is the NAND gate output. So A is equal to B, that means A dot B bar, A dot A bar, A dot A is A bar, which is NOT gate. So we can draw NOT gate from NAND gate. Similarly, NOT gate from NOR gate you can draw. So this is NOR gate. Combine the inputs, you will get a single input, A is equal to B. So A plus B bar is the output of NOR gate. So A plus A bar. So I take an input A, I got A bar, this is NOT gate. Next, a De Morgan laws. A plus B bar is A bar dot B bar. A dot B bar is A bar plus B bar. These are called De Morgan laws. By using the De Morgan laws, you can get AND from NOR, AND gate from NOR. Here no restriction of how many AND gates you can AND gate from NOR. How many NOR gates you can take? No restriction. Any number of NOR gates you can take. Finally, the output you should get is AND gate. So these two are the NOR gates. Input A, input B. So the output is A bar. This output is B bar. It is again NOR gate. So A bar, B bar, A bar plus B bar. Here NOR is there, not is there. Again bar you will get. So according to De Morgan laws, A plus B bar is A bar dot B bar. In the similar manner, A bar bar dot B bar bar. You will get A dot B. That is AND gate. So you can get AND gate from NOR gate. So this is the very useful usage. Next. XOR gate. XOR gate means extraordinary OR gate. That is called XOR gate. This is the circuit symbol of XOR gate. A input, A bar output. B input, B bar output for this NOT gate. And this A terminal is connected as a second terminal. And B terminal is connected as second terminal to the first AND gate. So the output of this is A bar dot B. The output of this is A dot B bar. Again you will add it, that is OR gate. So A dot B plus A bar dot B plus A dot B bar. This is called XOR gate, extraordinary OR gate. This is the circuit symbol of XOR gate. Now this is XNOR gate. XNOR gate, see, this is A bar, B bar, but A terminal is connected to AND gate, B terminal is connected to AND gate. So the output of this is A bar dot B bar and the output of this is A dot B. So again it is OR gate. Add these two, A bar dot B bar plus A dot B. This is called extraordinary NOR gate. So XNOR gate we can call it as. Next, NEET 2026 problem. What they given? NEET 2026 problem given on this logic gates. So see here, this is the circuit. This is the input signal they given. This is the circuit. So what they are asking, voltage across the diode they are asking. Usually up to now, voltage across the load only we taken in the previous exams. But a small change, that is voltage across the diode. So there are 4 options given. So third option is correct. See here, because ideal diode never be positive voltage across it. So first and fourth cancel. First and fourth cancel. Ideal diode never be positive voltage across it. Voltage across or it is the second one is, this is the graph across the diode, not across the diode, it is across the R. This graph is voltage across the R. These two are positive voltages. Okay, ideal diode never have the positive voltages. That is, ideal diode never have the positive voltage. So these two are not possible. This graph is possible if they ask the voltage drop across the resistor. But he asked voltage drop across the diode. So this is the best graph for that. So NEET 2026, another problem is given. See, 4 diodes are given. This is 10 volts this side, this is 0 volt, 4 ohm, 3 ohm, 2 ohm and 5 ohm. These two, first and third diodes are forward bias, second and fourth diodes are reverse bias. So what is the current? Current is voltage across first diode and resistor is 10. These are all parallel connections. So 10 volts only you will get. 10 by 4, that is 5 by 2. This is reverse bias. No current will pass. Again I3, 5. I4, 0. Therefore, the total current in the circuit from the battery, 5 by 2 plus 5, this is 15 by 2. Next, NEET 2025. So y is equal to A plus B bar dot A bar A dot B B bar. What is the output they asked? So this is the diode circuit they given. They asked the output. See, according to De Morgan laws, A plus B bar is A bar dot B bar. A dot B bar is A bar plus B bar. So if you multiply A bar dot B bar dot A bar, here dot is there, dot A bar, here dot is there. So dot A bar plus, here you will have dot, 1 minute, here you will have dot. So A bar plus B bar. Okay. So A bar dot B bar dot A bar dot B bar plus A bar dot B bar dot B bar. So A bar dot A bar is A bar dot B bar. B bar dot B bar is B, A bar dot B bar. So 1 plus 1 is 1. That means A bar dot B bar you will get. According to De Morgan laws, this is nothing but A plus B bar, which is NOR gate. In NEET 2025, this question was given. This is another NEET 2025 question. So input they given as 220 sine 100 pi t, and what is the which diode is forward bias, which diode is reverse bias after t is equal to 15 milliseconds. So from this a standard equation is V naught. A standard equation is, let it be V naught sine omega t, let it be. That is the standard equation. So compare it, omega is 100 pi, so 2 pi by t is equal to 100 pi, cancel it, the time period is 1 by 20, that is 20 milliseconds you will get, but asked for only 15 milliseconds. So that the total time period is 20, so up to this 10, then remain 5, it came down. That means D1 is reverse bias, D2 is forward bias. This is NEET 2025. So I am stopping here this session. So we will meet again in the next session. Thank you. Thank you. Please subscribe the channel for getting more and more videos from me. Thank you very much. Thank you one and all.